And welcome back. You may notice I'm wearing the same shirt I did in the last video. That's because for you, it's probably been a couple of days. For me, it's been about 2 minutes. So I've erased the board and we're ready to go again. All right, today's topic, the Pythagorean Theorem, and we're going to do some problems with the Pythagorean Theorem. And believe it or not, they're pretty much going to involve the square root property that we talked about last time. All right, so a right triangle is one that looks like this. It has a right angle, which is 90 degrees. And when you have a right triangle, we call these two sides that touch the angle, the right angle, those are the legs, and this is the hypotenuse. I'm never going to expect you to spell that. I had to look it up myself. Now, in a right triangle, we normally label them something like this. You don't have to use these letters, but in general, we're going to call this side A, and that green didn't show up very well for some reason. So let's go with A, and we call this side B, and the hypotenuse is C, and we give them those letters normally, but what's important is not that this one's called A, and this one's B, and this one's C. There's this thing, and it's called the Pythagorean Theorem, and it was developed by this group called the Pythagoreans, who were named after this guy named Pythagoras, who was a piece of work. And normally in class, I would tell you some stories. But since I don't want to waste your time, I won't tell those now. But they discovered that if you take A, the length of A, and you square it, and you take the length of the other leg, which we've called B, and square it, that's equal to C squared. Now, it doesn't matter that we call this A and B. What's important is that if you take the length of one leg squared, the length of the other leg squared, and add those together, it's equal to the length of the hypotenuse squared. These were some smart people, and they were able to figure this out and prove it for any triangle you could ever possibly draw that this is true. That's pretty amazing. They were very smart people. They were also just a little bit crazy, but that's okay. Now, you've used the Pythagorean Theorem before, and you probably at some place did some what's called plane geometry, and you did this, and you didn't use algebra, and that's fine. So you might have been given a triangle that looks something like this, and they told you, well, this length is 15, and the length of the hypotenuse is 25, and then they might not have used x, but they would have said, find the length of the side, the missing length. All right. And we would have used this theorem. Okay, one leg, 15 squared, plus the other one is x squared, and that one is 25 squared. All right, a squared plus b squared equals the hypotenuse squared. So now all we've got to do is work this out. Well, 15 squared is 225. So this is 225 plus x squared equals 625. You may have caught me just looking at my notes there. That's fine. We're going to solve this. Subtract 225. So x squared equals 400. Now we're going to take the square root of both sides. Very familiar concept if you've watched the last video. Okay, the last video has some rewards to it. And then take square root of both sides, so x is going to be plus or minus 20. Now, when we're talking about lengths or time or anything we're measuring, any kind of distance, time, things like that, and we do a problem and we get a positive and a negative answer, we're going to want the positive answer. So x is positive 20. All right? So for the rest of today, we're going to use the square root property, but the answer we're going to want is the positive answer. And you'll see I didn't do anything very advanced there. I just got x squared I used the Pythagorean theorem, I got x squared by itself, took the square root. And this one turned out to be a nice whole number. Everything was beautiful. Oh no, I've erased it. Now you don't know which is A and which is B anymore. And it doesn't matter which one's A and which one's B. It really doesn't. All right, so different triangle. This one has one leg is 12, one leg is 10, and the hypotenuse is x. How are we going to do this? We're going to do exactly the same thing we just did. All right, I know that a squared plus b squared equals c squared. Doesn't matter which is a and which is b, but I'm just going to say 12 squared plus 10 squared is x squared, because that's what I have there. Well, this is 144 plus 100. That equals x squared. This is 244. All right. Now, this is written backwards from the way we're used to doing it. We're used to seeing something squared. And if these two things are equal, I can change that order. I don't have to, but I just wanted to. All right. So x squared is 244. We're going to take the square root of both sides. Equals. And here's the deal. Let's say answer to nearest hundredth. All right. Nearest hundredth, what does that mean? That means 2 decimal places. 2 decimal places, that means I don't have to worry about simplifying that. I just have to put it in a calculator. And if you do that, you're going to get 15.62. Because I've already put it in my calculator. And again, I want the positive answer, so I didn't worry about the negative. All right, so also, you may have noticed that I wrote c squared equals a squared plus b squared the first time, and then I reversed it for this. It's the same thing. You know, if this is equal to that side, then you can change the order of the sides. That's not important. All right, so what we're going to do next is we're going to do a couple of word problems with the Pythagorean theorem. And rather than have you sit there and watch me in the video write these things out, I'm going to pause the video and then I will come back once they're written. So be right back. So here we go. Magically, this problem has appeared, and it says that a 12-foot ladder is leaning against a building. All right. If the bottom of the ladder is 7 feet from the building, how high is the top of the ladder from the ground? Then right down here it tells us to round to the nearest tenth. And that is beautiful, because that tells me that if I get an odd root, I don't have to simplify it. I just have to put it in the calculator. And that's great. So let me draw a picture of how this is going. All right, here's the deal. We have a building. There's your building. And then on the side of it, there is a ladder. Okay, and there we go. That is the limit of my artistic ability. So now I want to go in and I want to put the right numbers in there. All right, so let's look at it. The ladder is 12 feet tall. That means this is my ladder here, the diagonal one, the hypotenuse, you might say. That is 12. Now I'm going to redraw that just because I want it to look more like, wow, that's terrible. This is a right angle. All right, there we go. And then this is also flat. Not that that matters, but it's a little better now. But the ladder is 12 feet, so that's why that side is 12. What else do they tell us? They tell us the bottom of the ladder. Where's the bottom of the ladder? It's right here. Right? It is 7 feet from the building. So that tells me from the building to the bottom of the ladder, which is right there, this side is 7. So without even reading the next part, I know that that's the side I'm looking for. All right, how high is the top of the ladder from the ground? Yeah, how high is the top of the ladder from the ground? This is the side I want to find. Read it. Think about it. Draw a picture. It helps. And in the problems I give you, I try to spell out exactly bottom of the ladder. Okay, that tells you this side. But now that we've done that, the hard part's done. Let's solve this. Okay, I'm going to go back to c squared equals a squared plus b squared, although it doesn't matter. That's the way I'm going to write it. No. I'm going to be consistent. A squared plus b squared equals c squared, which means that x squared plus 7 squared equals 12 squared. So x squared plus 49 equals 144. I'm going to subtract the 49 from both sides. And I'm doing that part a little quickly because I think we've got that idea. 144 minus 49, that is 95. So x is going to be plus or minus the square root of 95. And I'm going to go over here and, well, actually it's right here, isn't it? Yeah, I'm going to consult this. And when I put that in the calculator, I get 9.7. Nearest tenth means 1 decimal place. All right. Again, put the things where they're supposed to go in the drawing. And once you have the drawing right, then everything follows through. A leg and leg. X squared plus 7 squared equals 12 squared. And then it's just solving for x. All right, I want to do one more of these, and I'm going to do the same thing. Rather than make you watch me, I'm going to pause it, and I'll be right back. And welcome back. Here we go. Last problem for today. And it's another word problem. It's another word problem involving the Pythagorean theorem. So here's what we're going to do. In the early afternoon, the tip of the shadow of a house is 10 feet from the house. All right, so here's the deal. We've got the ground. We'll make the ground green. And then we've got a house. And let's have a blue house for no particular reason. And just, we're going to make it a square house also. And you can like draw a door and a window or two. All right, there's our house. And somewhere over here is the sun, and this is a blue sun because, you know, yellow markers just don't show up. And then out here, it's casting a shadow. All right? Shadow's kind of falling out here. So there we go. There's our triangle. So let's fill in the numbers they gave us. They tell us that the tip of the shadow is 10 feet from the house. And I have left out a very important piece of information. Let's add this. Top of B. Okay. How far is the tip of the shadow from the top of the house? That's an important distinction because without that, I didn't know. All right. So, tip of the shadow from the house, that's going to be this side. Now, I'll be honest, I wasn't sure before, but I had to look. And when I looked, it's saying, how far is the tip of the shadow from the top of the house? This is the side they're asking me about. And they told me that this side is 24 feet because the house is 24 feet tall. All right, so that was a little tricky. I had to read to the end to get the information I needed, and I had left that out. I didn't just decide that. That was part of the problem. Okay, so I want to know how far is the tip of the shadow from the top of the house, the distance from the house to the tip of the shadow, which really does kind of make sense that you'd be measuring that on the ground. But that's 10. And there we go. This is what we needed. So what do we have? We have the hypotenuse squared is equal to the legs squared and added together. So x squared is going to be 24 squared, which is 400 and, yeah, I don't know. 576. I was very wrong. Plus 10 squared, I know, that's 100. So x squared is going to be 676. All right, so now x is going to be the plus or minus the square root of 676. And I don't quite remember that, so I'm going to walk over here and consult my notes. Yes, indeed, that's what I thought it was. It's going to be 26. Now, they told us to round to the nearest tenth, but we didn't have to because 676 is a perfect square. So, yeah, the answer is 26. So, in these word problems, don't freak out when you see a word problem. Just realize it's going to be a right triangle. Just get your numbers in the right place. Draw a little basic drawing, that helps. And then once you get your numbers in the right place, take this leg squared plus this leg squared equals that squared. And that's it. So that's the Pythagorean theorem. And that's all I have for this. Have a good one.